All right, in this section, we're going to be talking about properties of logarithms. And so there are three main properties of logarithms that we're going to be looking at. The first one says that the log base A of u times v. Now, u and v are going to represent many different things. Might be a number, it might be a function, a lot of different things that u and v could be. What we do know is that a, u, and v are going to be positive numbers in this situation, and a cannot be a 1. It never will be, but a value right here cannot be a 1 because you cannot raise 1 to a power and get a number right here other than 1. All right, so a, u, and v are going to be positive numbers, and n can be any real number. All right, so the first property here says that the log base a of u times v is equal to log base a of u plus log base a of v, which means if you have multiplication in between these two numbers right here, we can separate this into two logarithms, where we are taking the log of the first number plus the log of the second number. And likewise, if we have the log of u divided by v, we can separate this problem into two logarithms, where you have the log of u, which is the top value, minus the log of v, which is the bottom value. So looking at these, they're very similar. If you have multiplication in between two numbers here, you can separate this one logarithm into two logarithms through addition. And if you have one logarithm of two things that are divided, you can separate those into two logarithms with subtraction in between them. All right, so now the third property of logarithms is going to be log base a of u raised to the n power is equal to n times the log base a of u. What this means is that when you have an exponent up here, when you convert, you can bring this exponent to the front of your logarithm, and this will be equivalent to this value right here. Now, one of the things that you're going to see is that this process has a name for it, and if you look at this form right here, this is a condensed form. This is an expanded form. Same thing here. This is a condensed form of the problem, and this is an expanded form. And likewise, the same thing down here. This one is a condensed form of your log. This is an expanded form of your log. All right, so let's take a look at each one of these properties individually, first of all, and see how they tie together. All right, so this one we're going to be looking at property number 3, which means we can take the exponent that this is raised to, and that exponent can be moved to the front of your logarithm. And then we're going to be simplifying these. All right, so the first one here, you have log base 8 of x raised to the third power, which says we can bring this exponent to the front of your logarithm, giving you 3 log base 8 of x. That is what that simplifies to. This process right here, going from here to here, is called condensing. All right, so the next example here, we are going to do the same thing. We're going to bring the 5 to the front of our logarithm, which will give us 5 times log base 2 of 2. Now, we do know what the log base 2 of 2 is, or hopefully you do. What we're trying to figure out is 2 raised to what power gives you 2, and that is 1. So this breaks down then to 5 times 1, because 1 is log base 2 of 2, which gives you a final answer of 5. All right, so the next one, we're going to bring the 2, which is your exponent, to the front, giving you 2 times the log base 3 of 27. And then we need to simplify log base 3 of 27. And we're trying once again to figure out 3 raised to what power gives us this number. And that answer is 3. So this simplifies now to 2 times 3, which is 6. All right, so the next property that we're going to be looking at is the property where you have the log of 2 things multiplied together, and we can separate those 2 logs through the use of addition. And this property works both ways, which means you can take a condensed form of your equation, or a condensed form of your logarithm, and you can expand it, or you can take an expanded form and you can condense it. All right, so let's take a look at a little bit of both of these. The first one we're going to do is condensing the logarithmic expression. So we're going from 2 things being added together, and we're going to condense this from 2 logarithms down to 1 logarithm. So when you have addition with 2 logarithms where the base values are the same, you're going to multiply these 2 values here, u and v. So that's going to give us log base 2 of x times 3x, which would give us log base 2 of 3x squared. That is your condensed form of this logarithm. All right, so the next one, once again, we have addition, and they are the same base value. So this is going to go down to log base 3 of 5 times the x minus 1, which will give you log base 3 of 5x minus 5. That is the condensed form of these logarithms. All right, so we condensed by going from 2 logarithms down to a single logarithm. 2 logarithms down to a single logarithm. Now we could actually do this with more than 2 logarithms. We could have 3, 4, 5 logarithms that are added together, and you would just multiply each one of these numbers together. All right, so the next one we're going to do is going to be expanding a logarithmic expression. So expanding, we're going to go from 1 logarithm into multiple logarithms. So the first one we're going to look at is log base 5 of 7 times y, and there is multiplication in between the 7 and the y, so that's where we separate this into log base 5 of 7 plus log base 5 of y, and that is your expanded form. All right, so the next one we're going to do kind of the same thing. This is log base 6 of 10 times x squared. Because there's multiplication here, we can split that up, making it log base 6 of 10 plus log base 6 of x squared. However, this is not your completely expanded form, because what we need to do is use that previous property and bring this exponent to the front of your logarithm. So the completely expanded form is going to be log base 6 of 10 plus 2 log base 6 of x. So your expanded forms will not have an exponent on them right here. because you will bring that to the front of your logarithm always. This would be considered your condensed version when you have the exponent. All right, so now we're going to look at the other property, which was log base a of u divided by v. And so this logarithm can be broken up through the use of subtraction because we have two things divided by each other. All right, so let's look at the first one here, log base 5 of 15 minus log base 5 of 3. Because we have subtraction right here, we can combine these into log base 5 of 15 divided by 3, which is log base 5 of 5. And you should know that the log base 5 of 5 is equal to 1 because 5 raised to the first power is equal to 5. All right, so the next one, we have subtraction once again. So this goes down to log base 2 of 4x over x, which the x's will cancel on that fraction, leaving you with log base 2 of 4, which you should be able to simplify down to 2 because 2 raised to the second power is equal to 4. All right, so now the next one, we're going to look at expanding these, and we have division right here. So we have one logarithm. We're going to expand this into multiple logarithms. And so the first one will become log base 4 of the numerator minus log base 4 of the denominator. All right, so if you have division, we separate that and it becomes subtraction in between the two logs. All right, so the next one, we'll do the same kind of thing. This becomes log base 4 of x squared minus log base 4 of 7. However, once again, we have an exponent, so we need to bring that exponent to the front to give us the final simplified answer of 2 log base 4 of x minus log base 4 of 7. This is the completely expanded form of that logarithm. All right, so we can also use these properties to help us with solving equations, and that's what we're going to look at next. So right here we can see that we have two logarithms that are being subtracted from each other. Well, what that means is that we can condense or combine those two logarithms, and when you have them separated with subtraction, that means you're going to take the 8 and divide it by the x. So you have 8 over x is equal to log base 3 of 4 over 5. Now, one of the things to recognize here is that you have log base 3 on the left side of your equation and log base 3 on the right side of the equation. So if you have log of something equals log of something, what does that tell us about these two somethings? Well, it tells us those two somethings have to be equal to each other. All right, so that means we have 8 over x is equal to 4 over 5, which is a proportion. So we're going to solve this by cross multiplying, giving you 4x is equal to 40, or in other words, x is equal to 10. Okay, so the next equation, once again, we see that we have two logarithms on the same side of the equation, but this time those two logarithms are separated with addition, so we are going to condense those two logarithms, and those two logarithms condense through the use of multiplication, which would be 3 times x. All right, so what we see here is log base 4 of something equals log base 4 of something, and that means these two somethings have to be equal to each other. So that gives us our equation. 24 is equal to 3x, which means x is equal to 8. All right, so the next problem, if you look at this and you see, okay, log base 5 of 64, there's not too much that we can do with that. On the right side, you see x times log base 5 of 4. Well, if you remember the property of logarithms, what can we do with this number that's in front of your logarithm? Well, the property for condensing and expanding says that we can bring this value up to our exponent. So let's go ahead and move that, and that's going to give you log base 5 of 64 is equal to log base 5 of 4 raised to the x power. Now, like we had before, we have log base 5 of something equals log base 5 of something, which means those two somethings have to be equal to each other. And if you look at this, you're trying to figure out 4 raised to what power is equal to 64. And that would be 4 raised to the third power. Therefore, x is equal to 3. Now, another way that you can think of this is 64 is equal to 4 cubed. So if you have 4 cubed equals 4 to the x power, that means x has to equal 3. All right, so we're going to apply a similar concept to this next problem. Log base 9 of x, there's not too much that you can do here. Over here we have a number in front of the logarithm, which means we can bring that to the exponent to help us out. And so that's going to give you log base 9 of x is equal to log base 9 of 25 to the 1/2 power. Now 25 to the 1/2 power means square root of 25. So let's go ahead and simplify it down to that. You have now log base 9 of x equals log base 9 of the square root of 25, which is 5. And since we have log base 9 of x equals log base 9 of 5, that means x has to equal 5 in this situation.